Hi. So, we're going to do a little bit of high school geometry. Something that's pretty pivotal for high school geometry is the ideas of triangles and what we know and can find out about triangles. In geometry as a content really helps your child or student to understand how pieces and parts go together and to be able to take them apart, put them back together again, and be able to figure out what something means by looking at information that might not be central to what you think it is. So it's really about critical thinking, geometry is. So we're going to talk about this, an idea of congruence. So congruent, when we're going to talk about triangle theory or theories of congruence. So what you want to do is first cut out some triangles. I just used construction paper. You just need construction paper, some sort of straight edge, doesn't matter what it is, and just I would try to, you can do a right, remember right means this angle here is a square, so I'm going to put that there. So even if you don't have a protractor or any of the math, like traditional math tools at home, you can use tools that you just have around the house. So we're not going to be able to figure out exact measurements of angles if we don't have a protractor, but we can get some approximations. Remember last time we talked about angles, and an angle that is at the square, this is called a right angle. And then we also talked about acute and obtuse angles. So you can take a look at that on our YouTube channel. But anyway, let's talk about congruence and how do we know if triangles are congruent to each other. So what I did first of all is I cut off of 3 pieces of paper. So I know exactly that these are exactly the same. And all this congruence means is that it doesn't matter if you have it, this is called an orientation, how you have them pointing. That's the orientation of a triangle. So it doesn't matter how they're oriented. We know that these triangles are congruent because they have some exact measurements that we can figure out. And it's really cool because you don't have to measure every single angle or every single side. So for the parents who are guardians or caregivers who haven't been in school in a while, remember the angles, it's this measure. It's kind of like this motion of starting right here and kind of moving that along. That right there, that movement, measuring that curve kind of, that's the angle is right in here. So it's the measurement of how this curves from one side to the other. That's a layman's terms. And then the other things that we need to know or have measures of are sides. So with triangles, we're talking about angle measures and side measures. So this side right here, this has an angle. And we know then that in a triangle, every triangle has exactly 3 angles and exactly 3 sides. So you might be thinking, duh. But now we're going to get into like there's some very specific things about angles and sides, but it really is just angles and sides. So we're going to play with angles and sides. So we know that these, first of all, we know these are congruent because we cut them out of the exact same kind of paper. But we also know that we can measure different angles on these different triangles, and we can find one, like if, let's say I called this A and B and C. And I'm going to call this I'm going to call this A, B, C, D, E, and F. And G, A, B, C, D, E, F, G, H, and I. So you still have to do it. All right, so we have all these things. Now, the cool thing about triangles that we already know these are congruent, right? But what we can do is we can match up different angles on these 3 different triangles. So I'm going to go with my right angle first because that's one that I can check super quick. So let me tape these down so they don't move. Okay, so I know that angle C here is my right angle. It matches perfectly up. Hopefully you can see it there. Matches perfectly up in there. So I know that's C, and it should be exactly the same as some others. So let's see what it would be the same as in our yellow triangle. So we know it's not this one, right? We know it's not this one. So let's look at H, and there we go. So H is the exact same angle measure as C. So that means angle C is exactly the same as angle H. That should be the same as, hopefully, one of these. Remember, because we cut them together, angle F. Now, that was the one that made sense, right? Because the one that we could get easily. So now, if you don't have a protractor at home, you could prove that, because that's what, you know, it's fun when you can prove things through mathematics. That's what mathematicians think. And so let's prove some other things. So I'm going to look at this A. Now I'm going to mark it, and again, we're assuming we don't have the traditional math tools at home. So I'm going to mark a spot where I'm going to put right onto this A here. Put it right onto that A. And then you can kind of see through. See, you can kind of see that purple through. So there's this angle right here. I'm going to use that notation. So now, if these triangles are all congruent, as we say they are, this angle right here should match up with this one, and there you go. That means angle A is the same as angle, what was that, A, B, C, D. And then let's see, is it this one? No, it's not that one. So it should be, let's look down at there. Yep, exactly. So you can prove that these angles are the same. Now I would have your child do it for the last angle as well. So we know that all the angles are exactly the same. Again, we knew that because we cut them out together. But you can prove that on here. Maybe you cut out the triangles and then they have to, and put them down in different orientations and ask your student to prove that all those angles are the same. It also, when we have to make up our own tools, that helps us to know how we can figure things out in math. So we're not always going to have the fancy tools that you have at school. So let's figure out other ways that we can do things. That's what makes a creator society. We want people who can create. So then the other things that we have to measure on congruence is the lengths of the sides. So there are two things we can measure. Remember, angles and lengths of sides. So I'm going to use my favorite geometry tool, which is spaghetti. And I'm just going to see, and again, we're just proving to ourselves that these three triangles are indeed congruent. So I'm just going to prove to myself, here's my A to C right here. So I'm going to snap that off right there, A to C. So now this side right here, if these three triangles are congruent, it should go on to one of the sides. So let's see. Yep, exactly the same. Yep, exactly the same. So we know that this side is a measure that is exactly the same on all those. Well, let's look at the next one. We could look at this one right here. I'm going to lay that down, make sure it's right against your figure. And there we have this side. So then we can go back to here. Same in here. Now remember, this is an experiment, so it looks like there's a little smidge of human error on this one. Could be because I don't have my glasses on. All right, so we got this one. Let's make sure this one's okay. There we go. Smidgel different for human error on the cutting. Okay, so we can prove the angles are the same, and we can prove that side measures are the same. That's the one thing that we want to know first for congruence. So, but there are sometimes you don't know, you're just trying to demonstrate or prove to somebody else that two triangles are indeed exactly the same. So there are some theorems that we use, some rules. And the first one we're going to talk about is called angle, side, angle. So one thing that we've figured out as mathematicians, which is super cool, is that if you have an angle, a side the same, and another angle, and you're talking about two different triangles, that those triangles are congruent. That means everything's the same. Remember we just said, if triangles are congruent, everything's the same. They have the exact same three angles, the exact same three sides. So if we don't have all of those measures, which happens a lot in real life, and like, you know, you'll have one measure of a triangle, not the other one, you have to figure out what it is. That's where math comes in. And so if we have an angle and a side and an angle, let's see what something like that looks like. So I'm going to use my spaghetti again. So I'm going to make an angle here, and I'm going to tape this down just so that it doesn't move away. All right, so there's one angle. So now, because I can't move these pieces of spaghetti, that angle is not going to change. That angle won't change at all. So an angle, and then according to this theorem, the side has to be the same. So I'm going to, let's just keep this side right here. So we have this angle right here. And we have this side right here. I'll call that little a. We have this side A. And then, so we have an angle that goes here. This is an angle. This is a side. And now this is an angle. Now we can't look at this angle because it goes in order, kind of like you're reading a book. So angle, side, angle. But you could start here and go angle, this side angle, or you could start here and go angle, this side angle. But they all have to be kind of in order like that. So now, what do we know? Well, let's see. If this angle, I'm going to just make this into a triangle here. So if this angle is exactly that measure, and again, I don't know what that measure is right now because I don't have my tools. So if that angle is the exact same measure, that means if this thing right here, I'm going to put 2 dots on this one just so that we know. All right, so if this angle is the exact same measure, what do we know? Well, we know that it's going to cross on this bottom line at the exact same place, because let's play with it a little. So let's say we had this spaghetti coming out from here, and if it had a different angle measure, so hopefully you can see my spaghetti on top of the spaghetti. So again, I'm putting this on here. We know that the angle is made up of this side and this side, and we know that the way that this is tilted tells us the angle measure. So if it went out here, it would have a wider angle measure right here. If it went in here, it would have a shorter angle measure. So look what happens though if we have a shorter angle measure. This whole side changes then. So this whole side is chopped off. So you can have an angle that is the same, a side that is the same, but if you don't have this other guy, this other angle here, it's going to change the length of this side. So see, if I made it smaller than the angle, it makes this side smaller. And look what happens if I make it larger than the angle. So if I made this angle right here this large, we can't even, this line doesn't even go. So we would have to extend this line all the way until it reaches. So let's make it not quite so wide. So let's make it like this. What do you notice happens? So when you lengthen this angle right in here, what happens to the side that's across from it? Look what happens. This side is no longer long enough to hit the other side. So if this angle here gets bigger, you're going to need a bigger side to actually complete that triangle. So the angle's bigger, that means the side opposite it's bigger, and if that happens, then you know the triangles aren't congruent. But look at this one. If the angle's smaller, so if their angle goes in here and it's smaller, look what happens to the original side. So original side is like this. So if this angle is smaller than that angle, that side opposite it, that's what we call it. We say the angle and the side opposite, that's smaller too. So the only way for this original triangle down that we have down to be congruent with another one using angle, side, angle is if that angle, that side, and the angle, this exact angle is there, because that's the only way that this side will be exactly the same. And remember, we know that if triangles are congruent, all their sides and their angles will be equal. So this was just one of the theorems, the angle side angle. I'm going to do the other two next week, just so that we have practice on how to play with these ideas. With your student at home, if you have some spaghetti, I know I hesitate to use food as a tool, but they are really good tools. You can also use sticks or strips of paper if you want. Strips of paper you can maneuver like that as well. But let your student play with them for a little bit, and you can even color the spaghetti by soaking them in some food colored water. But play around with these ideas. Challenge each other. Challenge each other to have congruent triangles, and you make one using this angle side angle idea. So hope to see you next Monday. If not, hopefully you'll look for part 2, where we're going to talk about side angle side and side 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 on our YouTube channel or Facebook. So have a great day.